Welcome to Shanti-Peace for Mathematics. In this video, we will talking about sphere and some important results on the sphere. So first of all, vast difference between sphere and circle. A circle is a two-dimensional figure and the sphere is a three-dimensional figure. You can see the examples of a spheres are marbles, cricket ball. They are the examples of a sphere. So definition of the sphere is a locus of the point which remains at a constant distance from the fixed point. That means you will fix one point and the constant, all the set of points which are constant distance to this point in R2 it is called the circle. But now we are talking in R3, that is in third dimension. So all the points which are equidistant from the fixed point in R3 in the third dimension, it is called the sphere. So I have drawn this figure into two dimensions, but it is in the three dimension. So you can represent as a sphere. This fixed point, it's called the center of the sphere, and this fixed radius, which usually called as R, it's called the radius of the sphere. As per the definition of the distance formula, if you can see this fixed point is A, which is ABC, and if I take any point on this in this sphere as XYZ, then as per the distance formula we can say that x minus a square plus y minus b square plus z minus c square is equal to r square. So the distance between this point A and this point P on this sphere is, we say, AP. So we can say that AP is equal to R. And if I take the square both sides, then we will have, this is the equation. And this XYZ is any arbitrary point on the sphere. So that's why in general equation of the sphere is look like this, with center ABC and the radius is R. This is the first fundamental thing you should note here, that the equation of the sphere with center ABC and the radius R is this. Also, one should note that the family of the sphere, if you express this equation in this form, x square minus 2ax plus a square plus y square minus 2by plus b square plus z square minus 2cz plus c square is equal to r. If I can rearrange this and I can write down in this form, x square plus y square plus z square minus 2ax minus 2by minus 2cz plus this quantity a square plus b square plus c square minus r square, they are the constant. So in general equation of the sphere in the Cartesian or in the quadratic form can be written as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So this is in general equation of the sphere in R3, where this, if you compare with this one, you can just say that u is minus a, v is minus b, and w is minus c. So the center, if the equation of the sphere represented in this form, then the center of the sphere will be minus u, minus v, and minus w. And the radius you will get as square root of u square plus v square plus w square minus d. So this is the way you can represent any equation into the sphere. Now, if you can say that the radius of the sphere is 0, that means u square plus v square plus w square minus d is 0. It means that the sphere and this type of sphere is called the point sphere. So it's represent just a point. So this is the zeros or a sphere with the radius 0. So that's why this quadratic equation x square plus, or I can say ax square plus by square plus cz square plus 2ux plus 2vy plus 2wz plus d equal to 0. If you want to say this quadratic equation is represent the sphere, if this is A is equal to B equal to C, that is the first condition is required, another condition is required that u square plus v square plus w square minus d should be greater than or equal to 0. If this condition is satisfied and this are the satisfied, then in general this quadratic equation will represent a equation of the sphere with center. If these two conditions are satisfied, with the center minus u minus v minus w, and the radius is the square root of u square plus v square plus w square minus d. So this is the first things that we should note here. Let us move further. If you have a sphere and you know the what do you mean by diameter? Diameter is the chord which passes through a chord of the sphere which passes through the center. So this is the diameter. And you know that the end point of the diameter are A of x1, y1, z1 and B which is x2, y2, z2. So these are the information is given to you. If you have information with this, there are the extreme diameters, extreme points of the diameter are given to you. And if you want to find out what is the equation of the sphere, then you can find out using this formula, that is x minus x1, x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. So this is the equation of the sphere with having extreme point as a diameter. So if this you know this, then you can able to find out the equation of the sphere. Let us move further and discuss about the intersection between a sphere and a plane. In this lecture, I am just giving you introduction or giving you a theoretical portion or important results about the sphere and sphere. And in the next video, I will discuss what are the examples, and we will solve some examples related to these concepts. So when you have a given a sphere and a plane, there will be three possibilities are there. The first one is, let us discuss the first property. Suppose this is the sphere and there is one plane. The first possibility is the sphere does not intersect this plane. The second condition is this plane will be touched at one point, that is here is the point and this is the sphere, if this is the center of the sphere, and then it will touch this, and then in that case this is called the tangent plane. Okay, and the third possibility is the plane and the sphere, they are intersect each other, so it will intersect. Then you should note that there are three possibilities when someone asks you a question, what is the intersection or what is the possibilities of intersecting a sphere and plane. So there are three possible ways are there. There is no intersection. The another one is one point intersection, and there are infinitely many points as an intersection. So there are three possibilities. If there is a no intersection, what is the condition in which there is no intersection? So if the equation of the sphere is given to you, suppose the equation of the sphere is given x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is the equation of the sphere is given, and the equation of the plane is given is ax plus by plus cz equal to p. Then the center of this sphere will be represented as minus u minus v minus w, because this is the equation of the sphere. And if you can able to draw one perpendicular from this point to this plane, then you can observe that if this distance, let us say this is the point C, and this perpendicular you have drawn it as a cm. If this cm distance is bigger than the radius, that is the radius of this sphere, the radius of the sphere is this. If this is bigger than the sphere, then we can say that is no intersection. If this cm is equal to the radius of the sphere, then there is a one point of the intersection, and if the cm is less than radius, then there is a infinitely many points as an intersection. Okay, and the intersection will be a circle. That you can also observe that if you have one orange and if you cut that orange with the knife, then the intersection with that orange with the knife will gives you a circle. So that is a three possible way to represent this intersection between sphere and a plane. And using the formula, how to get this CM? The CM you can calculate it using this. If you can observe that the C bar, which is the center of this sphere, which is minus U minus V minus W. And if I can say that this n bar is the normal to this sphere, that is a normal, that's why I've drawn a perpendicular from this. So this is the CM, it is actually in the direction of the normal. So the normal of this plane, that is normal, is ABC, which is this coordinates, and minus P. So you can calculate this CM as C bar dot n bar minus P upon mode of n bar, and if this is greater than r, then we can say that there is no intersection. If C bar dot n bar minus P upon mode of n bar equal to r, then there is a one point intersection, and if this quantity is less than mode of n bar, then there will be a intersection, and the intersection is the circle. There is one more definition I want to tell you here is a great circle. So what is the great circle? A great circle is the plane which intersect the circle at the center of the sphere. So if the plane intersecting the sphere passing through the center of the sphere, then their intersection is a great circle. So that is the definition of the great circle. Now let us talk about the intersection between two spheres. If you have given two spheres, sphere 1 and sphere 2, let us say that sphere are given as x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 equal to 0, and another sphere is x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2z plus d2 equal to 0. Suppose there are two spheres are given to you. Now the question is, what are the possibilities of intersecting these two spheres? Let us discuss all these properties what we have here. Here I have drawn a two sphere. It does not look like sphere, but you can assume that they are spheres. And let us say that this is the distance, sorry, this is the center C1 of the first sphere, this is the center C2 of the second sphere. First, in this figure, we have noted that these two spheres are not intersecting. That means you can observe that this R1 and this is the R2. This R1 plus R2 is smaller than C1, C2. That is the distance between these two centers. If this is the situation, then there will be no intersection. That is the first things I have drawn here. The second possibility is that they are intersecting at one point. That means if this is the situation, this is the one sphere and this is the another sphere, then in this situation, this C1 and this is the C2 and this is the R1 and this one is R2. R1 plus R2 is actually same as C1 plus C2. Then we can say that they are intersecting externally. So they are intersecting externally, that is the one case is there. The another case that we can say about the intersecting two spheres is that they are intersecting or they are touched internally. So the situation is this. The third situation that we have is this. This is the first sphere and the center of that sphere is this. And there is another sphere which is lies inside the sphere, but it is touched the sphere. So this is the another sphere which is inside the first sphere. So what is the situation here? Here you have this C1 C2 is equal to actually mode of R1 minus R2, that you don't know what is the, so this is the radius R1 and this is the radius R2. So this distance is actually R1 minus R2. You don't know what is here in this figure. R1 is bigger, so that's why it is R1 minus R2. But it may happen that some of the figure we have R2 is bigger, so that's why we can write down mode of. So in this situation is C1 C2, that is the distance between this to center, is exactly same as modulus of R1 minus R2. This is the case where the intersecting two sphere internally. The fourth position or fourth possibility will be concentric circle. Concentric circle means there is one sphere and there is another sphere. Both have the same center. C1 is equal to C2 and the radius are different. So here the situation is C1 is equal to C2 and the R1 is not equal to R2. So this is the fourth possibilities are there where the two spheres are called concentric circles. Fifth possibility that we can talk is, and in this situation there will be no intersection. You can also observe that there is no intersection is there. The fifth possibility is there is one circle, the center is not same, but the sphere lies inside. So there is one center, there is another center. So C1 is not equal to C2, but one sphere is lies inside the another sphere. This is the situation where C1, C2 is less than mode of R1 minus R2. So in this situation, there is a intersection, no intersection is there. So there will be two cases in which there is no intersection. Okay. And the sixth possibility where there is infinitely many points where there is an intersection, that is the situation like this. So C1 center is C1, C2 is there and this radius, so what is the situation is mode of R1 minus R2 is less than C1 C2 is less than R1 plus R2. So in this situation there are infinitely many points as intersection is there and that intersection between these two spheres represent one circle. Okay, so one can ask you a question that what will be the intersection between two spheres if they are intersect. Then if they are intersect, then the intersection will be a circle. So here also in the case of two spheres intersecting a two sphere, there are three possibilities. The first one is there is no intersection. That is the case number 4, 5 and 1 are come into that. One point intersection, there is an internal intersection, sorry, externally intersect and the internal intersect is there. And the sixth point, there is infinitely many points which are having the intersection. Then in that situation, the intersection will be whole circle. So in R3, there is very important concept that you have learned here now. If you want to represent equation of the circle in R3, you cannot represent that equation of the circle with the form of one equation. Always, if you want to represent equation of the circle, you have to represent as a two equations. So what we have learned in here, we have learned that equation of the circle can be represented as intersection between sphere and a plane, also intersection between two spheres. Further, you also study that the equation of the circle can be represented also as between the cylinder, intersection between the cylinder and the plane, cone and the plane, and lots of other things, lots of other objects are there. So here the key point is you can remember that the equation of the circle you cannot represent as a one equation in R3. So in 3 dimension, if you want to represent equation of the circle, then it has to be represented as in this manner as per your course, that is intersection between sphere, that is this, together with some plane or between two spheres. So when you have given such type of situation, then you should note that the intersection of the sphere is never be, sorry, intersection of a circle is never be a one equation. It always together, the sphere and a plane or a two sphere as per your course. If you go further or if you go beyond your course, then it can be represented as an intersection between cylinder and a plane and so on. There are many ways to represent the equation of the circle. Okay, so that is the one more thing that we should mention here. Further, if you want to find out equation of the sphere passing through a circle, so the question is, there is one circle is given to you. This is the circle. And if you want to find out the equation of the sphere passing through this sphere, now whenever the circle is there in R3, it has to be, as I talked, that it has to be combination of the two things, either sphere and plane or two spheres. Then equation of the sphere, if the sphere is S1 and the plane is P, if I have in the previous here, if I can say this is the S, the sphere S, and if I can say this is the plane P, then intersection between these two sphere and plane will represent this circle. And you want to find out the another sphere which passes through this circle, then it can be represented as S1, or I can say this is S1 plus lambda P equal to 0. So this is the equation of the sphere passing through this circle. Also, one more thing here, we should note that if I can represent this is as S1 and this is as S2, the intersection between this S1 and S2 is also the sphere, suppose that. Then the intersection, or if you want to calculate the sphere which passing through this circle, that is intersection of S1 and S2, then it can be written as L S1 plus M S2 equal to 0, where L square plus M square is not equal to 0. So this theory portion, this much concept you need to discuss the examples, and we will discuss some practicals on this sphere in my next video lecture. Thank you very much for listening me. Till then, bye bye, sayonara, goodbye.